All right, in this lesson, we're going to talk about parametric equations and what that really is. Okay, so up to this point, right, if we read what's on the screen, we've been representing a graph by a single equation involving two variables, the x and y, right? So we have linear equations, we have quadratic equations, cubic, quartic, so forth. We have trig equations. Okay, so sometimes it's useful to introduce a third variable, t. And t we're going to refer to as time. Okay, and this is going to be called a parameter to represent our curve. Okay, and it's going to help kind of figure out like what direction are we going. And and we always think about time in the present, right? If I 0 seconds, right, means that time hasn't really begun, and then what's happening at 1 second, 2 seconds, right? I always love to do this example, right, when I'm talking about parametric equations. So let's picture my room. All right, so here is Miss Cardenstern's room. So Mrs. Cardenstern's room, and there's a door at the front of the room, my whiteboard. Okay, so if I call the door 0 seconds, right? So this is when time starts, is right here. Okay, and if I was standing right there, okay, that would be my position at 0 seconds. And then I decided to walk into the room. So maybe I start walking into my room here, and then I continue walking into my room, and I end up over here, right? So let's pretend that this was 0 seconds. This is 1, 2, 3, 4, 5, 6. Okay, so 6 seconds it takes me to walk all the way to my room. And so I could like graph this into some sort of graph. What happens if I didn't start at the door? What happens if I started because you know how it's my room here, there's a hallway down here, and then there's another classroom, Miss Barron's classroom. So Miss Barron, so B. So what happens if like I start here, or I start here along the line? Okay. Now all of a sudden, if I've said that this is 0 time, now I can go backwards in time. This is really minus 1 second, minus 2 seconds, minus 3 seconds. So now I can look at time and present. I can look at it into the future where I'm going, and I can also look at it into the past. Okay, so when we graph these parametric equations on just normal regular graph paper, we are going to have some things that are going to have negative time in it, and we'll have some things that have positive time in it. Okay, so I always like to do that description. Usually it's a little bit more clear when we're in a classroom and I physically walk into a class and then I can physically walk out of a class. Okay, but that's essentially what time is happening. Okay, so here's our definition of a parametric equation. So we have two functions. We're going to call them f and g, and they're continuous functions on the t interval. Okay, and so we're going to have two sets of ordered pairs. So if I plug in time, I'll plug it into the first function equation. I'll plug it into the second function equation. Right. So one's going to be your x, one's going to be your y, and all together, I'm going to get some sort of graph that we're going to call the curve, and so we're going to call it a giant C, okay? And so where time is our parameter. And so there's two ways that we can go ahead and focus on this. We can, the first way we can do this is by plot pointing, and this is actually the easiest way that we could do it. It can be tedious, so basically what that means is that you're going to start at a specific time, and you're just going to plug in different times into both equations to get a point. Then plot point. It's very simple and straightforward. Okay. We also want to make sure that we understand our direction. We are used to, okay, if I draw a graph, and let's just draw a line, right? So here's my lovely line. Okay, now notice that we have arrows in both directions. So this is telling us that I'm going in one direction, I'm going into another direction. Okay, when we talk about parameters, we only want to go in one direction. So we're actually not going to see arrows, right, at both ends. Okay, what we might see is we might see an arrow leading. So maybe this was the first point we plotted, right? And so we're going to see an arrow leading towards, right, our final time. Okay, or, right, maybe the same graph, right? If I graph it like this, again, I'm not going to draw arrows at both ends, but maybe this time I actually start, when I plot the points, I'm actually starting up here. And so my arrows would be pointing in the opposite direction. So what can be challenging sometimes is figuring out, right, where the arrows go, because these graphs would have the same slope, the same points, but one is clearly leading into one direction versus the other, right? So we definitely want to make sure that we've oriented our graph, and we just have arrowheads. As long as you have a couple, one or two, it will tell us where our direction is. I personally like to have arrows at every point along the way. Okay, because again, we're only taking a snippet of our time. So maybe our time starts at -2 and it goes to 3 seconds, right? We don't want to go further than that. The second way that we can do this, so this is number one, the second way we can do it is by eliminating the parameter altogether, taking away the t, right? So this is option number 2. So what we're going to do is we're going to solve for t in one of our parametric equations. We'll take a look at that, and then we'll substitute it into the other parametric equation, and we simplify into the rectangular equation. So again, we can see that polar equations and rectangular equations from our previous video are coming together in here. Again, the most important part, we still need to determine our values. So we need to determine kind of where we're going. Because again, if I was looking at this graph, let's just say that this was y was equal to, I didn't go through 0, so let's just say x plus 1. Again, I got to figure out where's my direction going, right? Am I going down? Am I going up? Am I going on forever? Maybe I actually don't go this far down. Maybe I actually stop right there, or I start right there. Okay, so we need to still look at our t values and kind of determine what is happening. Okay, so let's jump right into our first example, and I'll kind of show you what I mean by this. Okay, so here's example number 1. Okay, so we are going to find an equation in x and y whose graph contains the points on the curve C. We want to sketch the graph. Sketch graph of C and of C and indicate orientation. Okay, and here are our equations. So I'll draw them in red. So x is equal to 1 minus 2t. We have y is equal to 1 plus t. And I'm telling you that we are going to look in between our t, between -2 and 3. Again, t stands for time. Okay, so let me show you how we would do this with plotting our points. Okay, so if we plot our points, what I'm going to do is I'm going to set up a chart. So the first thing I'm going to do is I'm going to set up my time. So time is going to be -2, -1, 0, 1, 2, 3. Let's just use integers. We don't have to use decimals. If we want to, we can. And then I'm going to say x is equal to 1 minus 2t. And then leave a little bit of space. And then this will be y is equal to 1 plus t. And then leave a little space. And then this will be our x and our y coordinates. So basically what we will be plotting is this. Okay. All right, so let's go ahead and plug in what we know. So this will become 1 minus 2 times -2. So negative and a negative cancel each other out, leaving with +2. 1 plus 2 gives you 5. And then this will be 1 plus -2, which gives you -1. So this would be 5, comma, -1. So I come over here, so 5, boom, -1. There's my first point. And then I'm going to repeat this process. So 1, -2, -1. All of this is going to give me 3. and then 1 plus -1 gives me 0, so 3, 0. So notice that I'm going in this direction now. Okay, so I definitely will be adding some arrows in just a second. I'm going to plot all my points. So this will give me 1. Oops. It will also give me 1, so 1, 1 is right there. So -1, 2. And then 1 minus 2, 2. So -3. And last but not least, -5 and 1 plus 3 should give me 4. So -5, 4. So -5 and 4. Okay, so to the best of my ability, I'm going to draw, it looks like a line, right, through these points. I don't want to go past these points, okay? And hopefully you guys are using a ruler. So I'm going to start with my arrows, right? So I know that I led from this point. So here are my arrows leading to here. Now this pretty much looks like a line. Okay, again, my parameter is telling me I'm not going to go any further this way or this way. Okay, so I've sketched my graph. Cool, I've indicated direction. Now I just need to find an equation, right? So it kind of combines the second part. So what I want to do is I want to solve for t and y the equations. It seems like this equation is a little bit easier to solve for t. So I'm going to take y is equal to 1 plus t, and I'm going to subtract 1 to the other side. So y minus 1 is equal to t. I'm going to plug it in to that equation right here. So this will be x is equal to 1 minus 2 times y minus 1. So x is equal to 1 minus 2y plus 2. And since I see that no exponents are higher than 1 on both my x and my y's, it is a line. So I'm going to solve it for my line. So x is equal to -2y plus 3. Let's move it over to the other side. And I'm going to divide by a -2 or multiply by a half. So this will become -1/2 x, and then plus 3/2 is equal to y, right? So this should be my lovely equation down there. And that makes sense. I go down 1 over 2, down 1 over 2. I'm in between 3/2 is 1.5. And again, my graph is crossing it at about 1.5. Okay, so that's all that we're doing. We're sketching our parameters, right? We're just adding a different value for time. So go ahead and pause the video, and in the second part, we're going to come back to this same direction. So this will be example number 2. So same directions as before. So sketch, graph, orientation, and we want a rectangular equation. Okay, and here are our equations. So we're going to say x is equal to t, and y is equal to -2t. This time, I'm going to say our time is in between -2 and 2. Okay, so try this, see what your graph looks like when we come back in part 2.